Objective 10, more limits. In the last chapter, we looked at basic limits that gave us an indeterminate form, 0 divided by 0, and we also looked at expanding f of x plus h. We're going to put that together and look at this expression here. Limit as h goes to 0, f of x plus h minus f of x divided by h. It's very important. Right now, we'll go through the process. I'll show you how to calculate this quantity. And then at the end, I'll show you what significance is. This is the definition of the derivative, which is really the foundation of half of calculus. So we're going to start with f of x equals 2. And there's a four-step process we go through. Number one, we want to find f of x plus h. So we're going to find this term here in the numerator. Well, there's no x here, so if f of x is a constant 2, f of x plus h is a constant 2, so that's easy peasy. Number two, we want to calculate f of x plus h minus f of x. So we're going to expand and have the whole numerator. F of x plus h is 2 in this case. F of x is 2, and 2 minus 2 is 0. Step number 3, now we want to calculate this whole expression. F of x plus h minus f of x over h is going to be 0 divided by h. And we're going to simplify that to 0. Number 4. We basically shown that in this instance, when f of x equals 2, this whole expression simplifies to 0. It's not 0 when h is equal to 0, but if you back up here for a second, when the limit as h goes to 0, it approaches 0, we don't care what happens at 0. We only care what happens as we approach 0. Number 4, we're going to find the limit h goes to 0 of 0, and that's 0. There's no h to plug into, so it's just plain old 0. This is a fancy way of calculating slope. And if you think about it, this is a horizontal line. Slope of a horizontal line is 0. Now we have a linear function, f of x equals mx plus b. The slope is 5. We're going to apply this process. We better come up with a 5. Now, step number 1, f of x plus h equals 5x plus h plus 2. And we're going to expand that, 5x plus 5h plus 2. And that's all we can do here. Step number 2, f of x plus h minus f of x is 5x plus 5h plus 2. That's f of x plus h. Let me make a little annotation here. Minus, we want an original copy of f of x, 5x plus 2, and we need parentheses. That's f of x. Now we have 5x plus 5h plus 2 minus 5x minus 2, distribute the negative. 5x cancels, 2's cancel, and we have 5h. Step number 3, f of x plus h minus f of x over h equals 5h over h. And of course, h is canceled and we just get plain old 5. And step number 4, we want to take the limit h goes to 0 of 5, and we get 5. Like I said, that's a fancy way of calculating slope. That's the m in mx plus b. If all we had was linear functions, we wouldn't need this calculus, but unfortunately, we have a parabola. The slope of a parabola depends upon where we are. If you're right down here in the bottom, the slope is 0. Over here, for instance, slope might be 1. And then over here, the slope is negative. So we can find the slope as a function of x just by applying this process. Let's go ahead and do that. Need a little bit more room for that quadratic, so I'm going to clear some space here. Step number 1, f of x plus h is 2 times x plus h squared plus 5 times x plus h. Now to expand that, x plus h squared, that's a binomial squared. That's x plus h plus 5x plus 5h. And that's equal to 2 times x squared plus 2xh plus h squared plus 5x plus 5h. Then distribute the 2 through 2x squared plus 4xh plus 2h squared plus 5x plus 5h. That's expanded, and there are never any like terms at this point. It seems like there should be, but there is not. Step number 2, f of x plus h minus f of x. It's 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus f of x, which is this right here, 2x squared plus 5x. Now we can cancel. You can skip an easy peasy algebra step. This is negative 2x squared. It cancels with 2x squared. And it's going to be negative 5x cancels with a plus 5x. And so we're left with 4xh plus 2h squared plus 5h. At this stage, we better have an h in every term. If you're missing an h, you made a mistake. So number 3, f of x plus h minus f of x over h is 4xh plus 2h squared plus 5h over h. And now we can cancel that by factoring h out. And we have 4x plus 2h plus 5 divided by h. Cancel the h's. We have 4x plus 2h plus 5. And then step number 4, I have to reach pretty low here. We want to take limit h goes to 0. 4x plus 2h plus 5. We want to put 0 in for h. 4x and we get a final answer of 4x plus 5. That's the slope. If we're over here at some point for x, for instance, let's suppose we're at x equals 0. Plug in 0, we get a slope of 5. This thing's going upward with a positive slope. If you were at negative 2, x equals negative 2. 4 times negative 2 plus 5, you'd have a slope of negative 3. It'd be going in the downward fashion. So we have one more example to cover, and there's some good algebra to go along with it. Number 4. Okay, let's suppose we have f of x equals square root of x minus 2. We're going to follow a slightly different procedure here. We're going to do f of x plus h minus f of x over h all in one big step. And the reason is if you put x plus h in here and then minus 2, you can't really expand this in any simple fashion. Well, first of all, f of x plus h, you have to take this, put it in for x. We get square root x plus h minus 2 minus f of x divided by h. And if you look back to this h goes to 0, you could mentally plug in 0 for h. That becomes 0. On top you get 0, bottom you get 0. 0 divided by 0, indeterminate form. We talked about that last chapter. The way we rectify this situation is to multiply by the conjugate of the numerator. We want to rationalize the numerator. So we do square root x plus h minus 2 plus square root x minus 2 over square root Okay, that's a form of 1. And you'll see this ultimately will allow us to cancel out this square root right here. Or this h, sorry about that. That's our goal, get rid of that h. If we can get rid of that h, we can plug in 0 for h and find the limit. Well, on top we have the first product is x plus h minus 2. The last product is minus x minus 2. And you can check the O and the I cancel. That's plus 2 radicals, minus 2 radicals. That cancels. So we only need the first and the last term in FOIL. On the bottom, we're going to write h. And then we're going to keep this unmultiplied. And you'll see why. On top, we have x minus x is 0 and negative 2. This is really plus 2. I'll write it out. So we have x plus h minus 2 minus x plus 2 divided by h times square root x plus h minus 2 plus square root x minus 2. And we're left with h on top, divided by h square root x plus h minus 2 plus square root of x minus 2. And guess what? The h's cancel. So we have 1 over square root x plus h minus 2 square root x minus 2. And now finally, we can plug in 0 for h. We can actually take the limit. Let's call this step 1. I guess you can call this part D. We did A, B, and C, I believe, so we'll call that D. This is all step 1. Step 2, we want a limit h goes to 0, 1 over square root x minus 2. Okay, we can plug in 0 right here, and we end up with 1 over square root x minus 2 plus square root x minus 2. And our final answer is 1 over 2 square root x minus 2. And that's a slope function for this radical function right here. You could plot this out. It's not too hard to plot that function. Square root looks like this. This x minus 2 shifts it 2 units to the right. Does that. You could pick a point on here like 3, for instance. draw a tangent line. And if you substitute 3 here, you get 1 over 2 times square root of 1, which is 1 or 1/2. So the slope is 1/2. If you had an accurate piece of graph paper, you could reflect that. You could move down the line. The concavity means that the slope's going to decrease as we move to the right, as it would for this function right here. So, okay, that's all for this video.